In this video, we will continue our practice of combinations of transformations. So we'll be doing 2 or more transformations in a row and talking about that. So first, they want us to describe the series of transformations that would map triangle ABC onto A double prime, B double prime, C double prime. So we want to get from here to here, but it's going to take 2 transformations to do that. All right, first let's compare the original triangle ABC with triangle A prime, B prime, C prime. Hopefully you can see that these are reflections of each other. Now, what is the axis of symmetry between these 2 triangles? All right, I'm hoping you can see that this horizontal line right here would be the axis of symmetry, so it must be the reflection line. So if we were to reflect over this line, that would map the original triangle onto A prime, B prime, C prime. So that's the first phase of the operation. Now, this is the line y equals 1. Please remember that horizontal lines have the form y equals a number. So that's the line y equals 1. Okay, so phase 1, first, reflect over the line y equals 1. Okay, now compare how we might get from this purple triangle to this red triangle. All right, now this seems like a rotation to me. All right, it looks like if we start from here and we rotate this way, and see how they're both connected at point C prime? This would be the center of rotation because that's why they're connected here. So we could just rotate counterclockwise around point C prime 90 degrees. Okay? And I can tell it's going to be 90 degrees because A prime is right here. And then A double prime is right here. That is a 90-degree angle. So there you go. Then rotate 90 degrees counterclockwise around the point 2, 2. Of course, 2, 2, that's point C prime. That's where I got that from. For problem number 2, we need to do the following 2 transformations. First, we will reflect across the line x equals -1. Then we will reflect that across the x-axis and see what we get. The line x equals 1 is a vertical line. The line x equals -1 is a vertical line at -1. So this is what we are supposed to reflect over first. Reflect over the line x equals -1. So, since A is 2 spaces to the left of the line, A prime will be 2 spaces to the right. So this will be A prime. Since B is 4 spaces to the left, B prime will be 4 spaces to the right. C is 1 space to the left, so C prime will be 1 space to the right. So this is what we have after the first reflection. Next, we are supposed to reflect A prime, B prime, C prime across the x-axis. So let's take this purple triangle and reflect it across the x-axis. A prime is 5 units above the x-axis, so I'm going to go 5 units below. B prime is 1 unit above, so I'll go 1 below. C prime is 1 unit above, so I'm going to go 1 below. And this should be A double prime, B double prime, and C double prime. So this is the image after that second reflection. So we went from here to here to here. So now the final question is, what single transformation would map triangle ABC onto A double prime, B double prime, C double prime? So what single transformation would get us from the black triangle to the red triangle? And I'm hoping you can see that this is going to be a rotation. Okay, now imagine that this point right here was the center of rotation. Okay, if I were to rotate this around like this, then this triangle would end up here. Okay, see how the red triangle is upside down? Okay, this is what would happen if I rotated this. The A would wind up facing down. The C is just kind of rotating around this point and becoming C prime. Okay, so this is a rotation. Now, how many degrees is it? This is going to be a 180-degree rotation. I know because the entire thing is winding up upside down. Okay, when you do a 90-degree translation, if you have a triangle like this and you go 90 degrees, all right, it's going to end up like that. All right, let me do it as an arrow. If you have an arrow and then you rotate it 90 degrees, it's going to end up pointing the other way. All right, but if you have an arrow that's facing up and then you rotate 180 degrees, okay, then the arrow is going to end up facing down. So that's what's happening here. All right, A is pointing up, now A is pointing down. This is a 180-degree rotation. Okay, and around the center, we have to be careful. Notice that it's not 0, 0 that's in the middle of this thing. It's this point right here, the point -1, 0. And it's easy to tell. If you look at C and then you look at C prime diagonally, notice how this green dot is the point that's right in the middle of them. So if you want to map ABC onto A double prime, B double prime, C double prime, you rotate 180 degrees around the point -1, 0. All right, for problem number 3, we need to perform the following transformations. We need to dilate from the center 1, -4 by a scale factor of 2/3. Interesting. Then we will rotate that image 90 degrees counterclockwise around point A prime. All right, this is going to be interesting. All right, we are supposed to dilate from the point 1, -4. In other words, 1, -4 is the center of dilation. So we should plot that point. You know what? I wanted to use green for some reason. All right, this is the center of dilation right there. So, if you want to do a dilation from this point, you need to ask yourself what path you would have to take to get from the center to each point. Okay, so, for example, if I wanted to get from the center to point A, I would have to go left and then up. Okay, now how many was that? Okay, so that was left 1, 2, 3, 4, 5, 6. So that was left 6. Let me just write that down. So I went left 6, and then I went up, how many? 4, 8, 9. So I went left 6 and up 9. So to get to point A, I had to go left 6 and up 9. Now remember that the scale factor is 2/3. So I need to multiply each of these motions by 2/3. So I need to take 6 and I need to multiply that by 2/3. I need to take 9 and I need to multiply that by 2/3. And that is going to tell me where A prime is going to be. Okay, or how to get there anyway. So if I do 6 times 2/3, remember that this is really 6 over 1. 6 times 2 is 12, divided by 3 is 4. So this will be left 4. 9 times 2 is 18, divided by 3 is 6. So this will be up 6. So left 4, up 6. Okay, so that's how you get to A prime. So let's do that. So counting from the center, I'm going to go left 4 and up 6. So here I go. That's 2, 4, and then up 1, 2, 3, 4, 5, 6. So this should be A prime. All right, let's do that again. This time, let's talk about point B, and we'll see what has to happen. So to get to point B, I would have to go up and to the right. So let's see, this is, that's 4, and then an additional 5. So that's up 9 and right 3. So to get to point B, I have to go up 9 and right 3. Okay, so if I want to get to B prime, I'm going to have to multiply these motions by the scale factor. So I need to multiply by 2/3, and I need to multiply by 2/3. And that should give me the location, or how to get to B prime. So if I want to get to B prime, let's see, 9 times 2 is 18, divided by 3 is 6. So I'm going to need to go up 6. 3 times 2 is 6, divided by 3 is 2. So I need to go right 2. So up 6 and right 2, that should take me to B prime. Starting from the center, I will go up 6 and right 2. So this should be B prime. All right, let's do that one more time for point C. Okay, to get to point C, I'm just going straight up. I would simply have to go up 6. Okay, to get to point C, I would go up 6, and that is all. So if I want to figure out how to get to C prime, I need to multiply that by 2/3. And that will tell me how to get to C prime. 6 times 2 is 12, divided by 3 is 4. So I need to go up 4. So let's do that. Starting at the center, if I go up 4, that's going to put me right here on the x-axis. So this should be my C prime. So this is what we have so far after a dilation of 2/3 from the point 1, -4. So that was just the first translation. We're only halfway done. Next, we need to rotate 90 degrees counterclockwise around the point A prime. Now, there's two ways that we have learned to do a rotation around a point that is not the origin. Method 1 was the method where we move everything to the origin and back. All right, this is the method that we have to do if we don't have a graph. Method 2 is called the arrow method. And if we have a graph, we can do the arrow method, and it really turns out to be similar to what we've been doing with these dilations. So I'm going to use the arrow method this time. Okay, so we want to do 90 degrees counterclockwise around the point A prime. Okay, so let me just erase the old center. We're done with that for now. So focus your eyes on A prime. This is what we're going to rotate around. So first of all, oh, sorry, I put the dot on A. I meant to put the dot on A prime. This will be the center of rotation. This is what we're going to rotate around. So if I'm going to do a 90-degree rotation, okay, let's start with point B. This should be easy because a 90-degree rotation, this is already a horizontal line. Okay, if I take a horizontal line like this and I rotate it 90 degrees, let's see, did they say counterclockwise? Counterclockwise. All right, counterclockwise is in this direction. Okay, like this. So this would be a 90-degree counterclockwise rotation around this point. So a horizontal line will just go vertical, okay, because that's what 90 degrees means. So that part is going to be simple. So B prime is going to go from being horizontal, and notice this is 6 apart. So if I rotate 90 degrees counterclockwise, it should be 6 straight up. So this is going to go off the graph a little bit. So this is 4, this would be like about 5, and this would be about 6. Okay, so it's going to be roughly here. So this is going to be my B prime. All right, I think I'm just going to go ahead and draw that as well. Okay, so there is our first piece. All right, now, point C is going to be a little bit trickier, but that's really the last thing I'm going to have to do. All right, here's how I'm going to get point C. Let's look at the path again. So from the center of rotation, which is this green dot right here, let's think about how I would get to point C. And I'm going to make a big L out of it. Okay, if I wanted to get to point C prime, I would have to go down 2 and right 4. Okay? All you really have to worry about is the L, because all I need to do is rotate this L 90 degrees around A prime. Okay, let's practice off to the side. Let's see what it looks like when you rotate an L. Okay, this is the center of rotation. So if I have this, and I want to rotate this 90 degrees. Okay, so I'm rotating counterclockwise. But look, this vertical piece is going to wind up horizontal. Okay, that went from straight down to the right. So there, I've rotated that 90 degrees. Okay, that's the short piece. Now we can just draw the rest of the L. Okay, the long piece of the L is just going to be like that. So this is what it will look like if we rotate this L 90 degrees. All right, the vertical piece will be horizontal. The horizontal piece will become vertical. It's very simple. Okay, and now remember what these lengths are. This is length 2 and 4. So after the rotation, the lengths should be the same. It should be still 2 and 4. Okay, so it's going to be like this. So if I go over 2 and up 4, that should be the location of C prime, all right, because of the L. All right, see the green L? Here's what it would look like if I rotated that green L 90 degrees. Boom. All right, see how the green L went from here to here? But point C prime is at the end of the L. So point C double prime should be at the end of the L after the rotation. I made one small mistake. I mean a really small mistake. I called this B prime. But this is, when you move B prime, it becomes B double prime. Okay, so this is really B double prime. And this will be C double prime. And this point that's not moving is the point A prime, but it's also the point A double prime as well. All right, so now I can go ahead and draw the triangle. Okay, so hopefully now you can see that the purple triangle has now rotated from being horizontal to vertical, and that is 90 degrees. All right, so there's your final picture. For problem number 4, we need to circle all the transformations that would map this square onto itself. So we are talking about lines of symmetry. So look, first they say the line y equals x. Remember that the line y equals x is a diagonal line like this. So the only question is that a line of symmetry for this square? And sure, it is. All right. The top half of this rectangle, to above and to the left, is identical. It's the mirror image of the lower part. So the line y equals x is a line of symmetry. So if I did a reflection over this, it would still look the same. So we'll circle that one. Okay, what about a reflection across the line y equals negative x? Okay, what would that look like? Now the line y equals negative x is a downward sloping line like this. All right, notice that it doesn't pass through the square at all. So look, here's the original square right here. All right, let me change colors for a second. All right, if I did a reflection over the line y equals negative x, it would be like this. All right, can you see that this would be the mirror image over this diagonal line? These are not the same. This is not falling back on itself. All right, so this is a no. We are not going to circle that one. Now, how about a 90-degree clockwise rotation around the point 3, 1? Okay, let's see. All right, the screen's jumping around on me. Okay, so here's the original image again. The point 3, 1 would be right here. Okay, here is the point 3, 1. If I rotate 90 degrees, okay, so I'm rotating like this. If I spin this around this green point like it's a hinge, I'm hoping you can see that it's going to end up like this. Okay, if I rotated 90 degrees, the black square would become the blue square. All right, if I'm rotating around the point 3, 1. So that will not put the square back on itself. So I'm not going to circle that one. Okay, what if I rotate 180 degrees around the point 1, comma 1. So understand that the point 1, comma 1 is this point right here. So I'm going to be rotating around this point, okay, 180 degrees. So what's going to happen is, okay, if this is the original position, if I were to rotate 90 degrees, it would end up here. If I rotate 90 degrees again, it would end up here. So this is what a 180 degree rotation around this center would be. Notice that they do not line up. You do not find one on top of the other. So we're not going to circle that one either. So this first one, a reflection across the line y equals x, is the only one that would map the square onto itself. All right, now they didn't put the following one on the list. If they had given any kind of a rotation around the point 2, comma 2, if they had said around the point 2, comma 2, whether it was 90 degrees or 180 degrees or 270 degrees, then it would map the square onto itself, okay? Because every time I turn it, because the center is right in the middle of the square, no matter how I turn it, the square is going to still look the same. But they didn't say, they never said 2, comma 2 as a rotation point. All right, so moving on. All right, for the second part of number 4, we need to fill in the blanks that would map the square onto itself. We have a reflection across x equals something. All right, that's a vertical line, by the way, vertical. And we have a 180 degree rotation around, and we need to fill in the point. The easiest way to make sure that this square gets mapped onto itself is by making sure it doesn't move with either one of these transformations. All right, it's going to stay the same the entire time. Watch this. First, let's talk about the reflection across the line x equals something, a vertical line. So let's think about a vertical line that we could use that would not change anything if I did a reflection. In other words, what is the vertical axis of symmetry? It's this. All right, this vertical line is an axis of symmetry for this square. This is the line x equals 2. If I did a reflection over this line, nothing would change. All right, it would just flip and it would be identical. So if I reflect across the line x equals 2, so far nothing moved. Now I want to do a 180 degree rotation, but I don't want anything to change. I want it to look the same. So where does the center of rotation need to be? Where is the center of the square? Because that's what I need. Can you see that the center of the square is right here? If I rotate, as long as I'm rotating around the center of the square, it's just going to turn upside down and it won't look any different. So the center of the square is the point 2, comma 2. So there it is. Rotate 180 degrees around the point 2, comma 2. All right, problem number 5. The point 3, comma 5 is rotated 180 degrees around the origin. And then, so then now you have P prime. That's reflected across the x-axis. All right, what are the coordinates of P prime and P double prime? So first, we're going to get P prime by rotating 180 degrees. Well, when you rotate around the origin, we have memorized a rule for that. xy becomes negative x, negative y. When you rotate around the origin, that's the one where the signs simply change. Okay, so P prime in that case should simply be negative 3, comma negative 5. So now we will take that and we have to reflect across the x-axis. We know a rule for that. When you reflect across the x-axis, the x value stays the same, the y value changes. So in other words, xy becomes x negative y. Only the y value changes. So that means the x value of negative 3 will stay the same, and the y value will become positive 5. So that should be p and p double prime. All right, the second part of number 5 is interesting. They want to know, how could we map the original point P directly onto the final point P double prime in one step? Well, look at the points and look for the pattern. So the original point P was 3, 5, and then that became, in the end, the point negative 3, 5. Okay, so what happened? xy became negative xy. All right? In other words, the y value stayed the same. The x value changed. So what reflection has this rule? If you reflect across the y-axis, that's when the y value stays the same and the x value changes. So there you go for number 5. All right, last problem. The point M, negative 4, negative 2, is reflected across the y-axis. And then M prime is rotated 90 degrees counterclockwise around the origin. What are the coordinates of M prime and M double prime? So first, when we reflect across the y-axis, the y value stays the same. So M prime is going to be positive 4, negative 2. The y value stayed the same, but the x value had to change. So 4, negative 2. Now it's time to do our 90-degree counterclockwise rotation. Now, when you do a 90-degree rotation, the x and y definitely switch places. So xy becomes. Now, the y is definitely going to go first, and the x is going to go second. But one of them, the sign will change. And one of them, the sign stays the same. When you're going counterclockwise, it's the x value that stays the same. And the y value has to change. Okay? So that's what we're going to do. So the y value is going to go first, but that's the one that has to change. So negative 2 is going to become positive 2. The x value will go second, and it doesn't change. So it will be 2, 4. So that's M double prime is 2, 4. How can we go from the original point M to M double prime in one step? Well, again, the original point is negative 4, negative 2. And then the final point is the point 2, 4. So what happened? All right? In other words, we had xy and it became. So 4, 2, 2, 4. The x and y reversed. But also both signs changed. So xy became negative y, negative x. All right? They reversed and they both changed signs. What kind of reflection does that? All right? That's what happens when you do a reflection over the line y equals negative x. All right? That's something that we have simply memorized, that a reflection over the line y equals negative x is where you reverse them and change both signs. So there you go. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.